9.2 on similar polygons. We're going to determine whether each pair of polygons is similar, and we're going to justify our answer. So I'm going to make a little note up here. For polygons to be similar, you need two things to happen. You need the corresponding angles to be congruent. So if you have four-sided figures, you need four pairs of congruent angles. You also need the corresponding sides to be proportional. And remember what that word means. That means you end up with the same ratio. So if you have four-sided figures, you're going to write four ratios, and you need to make sure they're all the same. That would make them proportional. If those two things happen, then the figures are similar. So let's look at this first example. Notice how all of the angles are right angles. So the corresponding angles here are congruent. We need to check to see if the corresponding sides are proportional. Well, we just learned last chapter that these figures are rectangles, so obviously the opposite sides are congruent. So the smallest side on this shape is 3. I'm going to compare that with the smallest side on this shape, 6. Biggest side is 4. Compare that with the biggest side over here, 8. 3/6 equals 4/8. And if you're not sure, I'm going to show you how to do this. 3 divided by 6 is 1/2. 4 divided by 8 is 1/2. So just like we did in the last section, you're just reducing ratios. If they equal the same thing, then your corresponding sides are proportional. So we have corresponding angles congruent in this example, and we have corresponding sides proportional. So they are similar. Okay, and this would justify your answer. Obviously, you can see all the pairs of angles are congruent. Number 2, again, we have two rectangles. And if you examine this even closer, they're rhombuses also, because all the sides are the same. So what do you call a rectangle that's a rhombus? This guy's a square. Now, you didn't need to do that, but I'm going to show you why it helps you. If they're squares, then obviously you know the corresponding angles are congruent. They're all 90. If they're squares, notice how all of these sides are 2. All of these sides are 5. So when you compare all of the sides, you're going to get 4 ratios of 2/5. So of course they're similar. If they're squares, any two squares are similar. So that's a little hint for you, or a little thing to remember. If you see two squares, of course they're similar. You don't need to spend time checking ratios. They're going to end up being the same thing. Let's look at number 3. We have two rectangles again, so the corresponding angles are congruent. Are the corresponding sides proportional? Let's compare. The shortest side on the small one is 1. The shortest side on the big one is 3. Biggest side on the smallest is 2, and the biggest side on the biggest is 5. Does 1/3 equal 2/5? Absolutely not. These are not similar because the corresponding sides are not proportional. So what we can take from this is two rectangles are going to have corresponding angles congruent, but the sides don't have to be proportional. All squares are similar, all rectangles, maybe not. So watch yourself. Here's number 4, and this is a good one to look at. This figure's a rhombus, and this figure's a rhombus. This one also happens to be a rectangle. This one's not a rectangle. Are they similar? Look at the corresponding angles. Are they the same? Corresponding angles are not congruent. So not similar would be your answer. Here's an example of two equilateral triangles. They behave a lot like the squares as far as similarity goes. All of these angles are going to be the same. They're all going to be 60. All of the sides are the same, so when you write their ratios, they're going to be the same as well. Same thing with this shape. you have equal angle measures, so your corresponding angles are congruent. Now, when you write your corresponding ratios for the side lengths, they all equal 6/10. So they're going to be similar also. So some of these you don't have to do a lot of math with. Most of the math from this page comes from this section. They're telling you if they're similar. So you're assuming that these are similar figures. So then over here you know 6 things. Here you know 8 things. Here you know 8 things. Find the values of the variables. Okay? Well, if these are similar, I need to find what x is. What does x go with? I don't have a similarity statement to check. But what I do have are the markings on the figures. That's important. Notice how the x touches an arc with an angle with one arc and an angle with the right angle box. So the x goes with the 16. And I know that x is smaller than 16, so I'm putting my smaller numbers on top. I know that 6 goes with 12 because of the markings, not because they're both on the bottom. Now, I don't need a calculator for this because I know that 6 is half of 12. So what's half of 16? 8. I'll use the same concept here. The similarity ratio is 1 to 2. So this ratio is 1 to 2. So y is 8. Y is 8. No, y is not 8. Okay, what does y correspond with? Y corresponds with that 20. So y is 10. I fooled myself there for a second. Number 8. These are squares. All the sides are the same. All the angles are the same. They're telling you they're similar, so if that's a square, that's a square. So x and y are both 30. Not a whole lot of thinking involved there. I'm going to move down and do one that's a little more challenging and leave some of these for you to practice on your own. These two figures are similar. This is a really good example to do because notice how this guy is kind of rotated. It's not just a translation and an enlargement. Okay, so what does the x go with? The x touches the two right angles, so 10 goes with x. 10 is smaller than x, obviously. It comes from the smaller figure. This 9 touches a right angle and 2 arcs. So does that 6. So 6 to 9 is my similarity ratio. I'm going to do 10 times 9, and then I'm going to divide by 6. Okay, so 90 divided by 6 gives me 15. I also need to find y, and I'm going to use the same ratio 6/9. And if you wanted to reduce this guy to 2/3 because you know it's 2/3, you can. So all of these corresponding side lengths need to be in a ratio of 2 to 3. What's the y go with? Touches a right angle and an angle with one arc. It goes with the 16. Make sure you put your 16 in the correct place, otherwise you're going to get the wrong answer. 16 is definitely smaller than y. It comes from the smaller figure. So let's cross multiply. 9 times 16 and then divide by 6. You do the rest of these exactly the same way.